Page 32 of our notes, hardcore trigonometry here. So if you haven't yet memorized, remember Mrs. Ford keeps talking about that gets this memorized, that gets this memorized. Get your gold sheet out because you need to refer to it in order to answer these questions. But again, within the next couple days, guys, that has got to be memorized. All right, so here we go. Section 4.2, we are going to find the value of all 6 trig functions for theta. So here is the picture. This is not hard. All this is labeled for you, and there is theta. Now, with regard to theta, this side over here, look where I'm pointing. This side over here is the opposite side because it is across from the theta. This side right here is the adjacent side, and that of course is the hypotenuse. Now again, I put those labels on there based on where my theta is. The angle, the side across from the theta is my opposite. Now, my job is to fill in sine, cosine, tangent, and then the reciprocal functions, cosecant, secant, and cotangent. So again, if you're starting to memorize that gold sheet, or better yet, if you already have memorized it, you know that these are reciprocals of each other. So if we can remember SOHCAHTOA, sine is what? Opposite over hypotenuse. So looking up here at our picture, opposite over hypotenuse would be 2 over root 13, right? Which means cosecant is root 13 over 2 because these guys are reciprocals of each other. Now, see that answer right there? What's wrong with that? Why do I not like that answer so much?
Because it's a radical.
Because there's a radical in the bottom?
Yeah.
So do you remember how we fixed that? Multiply by root 13. If I multiply top and bottom by root 13, what does that end up giving me? 2 root 13 over
1.
No, not 1.
13.
So 13 over 13. Root 13 times root 13 is 13. That's why we multiply by root 13, so that it turns that into a plane 13. Now, do I need to do that over here with this guy?
No.
No, because over here the radical is on the top. Not a problem. All right, what about cosine?
Adjacent.
Cosine is adjacent over hypotenuse, so that would be 3 over root 13, which means secant is root 13 over 3. Remember, cosine and secant are reciprocals. They're flips of each other. So if I know what the cosine is, the secant is automatically just going to be the flip of it. Now, what about this one? Do we have the same problem?
Yep. 3 root 13.
So that's going to be 3 root 13 over 13.
Yep.
If I multiply the top and bottom by root 13. What about tangent? What's tangent?
Opposite over adjacent.
TOA. Opposite over adjacent. So that would just be 2/3.
Yep.
Which means cotangent is
3
halves. Done. That is an incredibly easy problem, unless you don't have your definitions memorized. If you don't have them memorized, then of course you're kind of in trouble. All right, let's look at B. B is exactly the same problem. I'll try to draw a better triangle than that. Okay, we have 13, 5, 12, and this time pay attention where theta is, because that's the important piece. because wherever theta is, that's what's going to determine adjacent and opposite, right?
Yes.
This is hypotenuse, no matter what.
Your opposite will be 5.
But the opposite is going to be 5, and the adjacent is going to be 12, right?
Yep.
So now I'm ready to do sine, cosine, and tangent, and cosecant, secant, and cotangent. All right, so here we go. What's sine?
5 over 13.
5 over 13, which means cosecant is 13 over 5. See how this is working? What's cosine? 12 13ths. So secant is 13 12ths. What's tangent?
5 12.
5 12ths, which means cotangent is 12 fifths. Now let's look at C. There's a couple of things different about C. First of all, I didn't write out all the functions. You're going to have to do that on your own this time. So you're going to write sine, cosine, tangent, cosecant, secant, and cotangent. And I would recommend you get in the habit of writing them in that order because that reinforces that reciprocal relationship. Now this time, what else is different? Look at that picture. What else is different about it? What?
There's a side missing.
There's a side missing. Now, you need all the sides. In order to fill in all of these, you need all the sides, right?
Mm-hmm.
This is a right triangle. If I know two sides of a right triangle, can I find the third side? How?
Okay, you just place the hypotenuse as x, and then just solve from there.
How would I solve that, Max?
Well, I mean, like, because you know that your opposite's going to be 3 and your adjacent's going to be 1, and you just go ahead and place that hypotenuse as like x, and then just fill in from there.
And then have x's in my answers? No, I don't want to do that. I could, but that isn't the best way to answer the question. Huh? Pythagorean Theorem. Everybody remember the Pythagorean Theorem? It's one of those big things, folks. If you know two sides of a right triangle, the third side should be automatic for you. So, what I'll call it x for now, Max. My Pythagorean Theorem would say 1 squared plus 3 squared equals x squared. So 1 plus 9 equals x squared. What is my x going to equal? Square root of 10? And that is my hypotenuse. Now here's theta. So which side's opposite?
3.
3. Everybody good with that? You got to be able to identify that. That's opposite, which makes this adjacent. Why is that opposite? Because it's the one, if I were to flick that theta straight across the triangle, this is where it would go. This is the opposite, right across from the angle. Okay, what's my sign?
3 root 10.
Okay, she's already rationalized. She said it's 3 over root 10, which makes cosecant root 10 over 3, but she didn't like the way this one looked. So she rationalized it, excuse me, and got 3 root 10 over 10. Christina, you with me? What about cosine? 1 over root 10, which is root 10 over 10, 1 root 10 over 10. Multiply top and bottom by root 10 here. Everybody understand why the secant's just root 10? If the cosine was 1 over root 10, if I flip that over, I get root 10 over 1. Right?
Yep.
What's my tangent? 3 over 1. So the cotangent is 1/3.
Yep.
All right, on this lovely Tuesday morning, let's have you try number 4, or D, letter D. Let's have you try that one on your own. So, write down all the functions. These are the functions that you're finding. Sine, cosine, and tangent, and then cosecant, secant, and cotangent. And before you start, what are you going to have to do again?
Pythagorean Theorem.
You're going to have to do the Pythagorean Theorem. Now, caution, caution, caution. What's the Pythagorean Theorem going to say?
5 squared plus 2 squared.
2 squared plus x squared equals 5 squared. When we do the Pythagorean Theorem, a squared plus b squared equals c squared, right? What's c? Hypotenuse. The hypotenuse. So 4 plus x squared equals 25. Did you get root 21 for this missing side? If you got root 29, you didn't do it right. The hypotenuse is always the one by itself. It's always the c squared. Now, where's the theta in that picture? Right here? That's important, because that tells me which side is opposite.
Oh, the root 21.
Root 21. Which side is adjacent?
2.
Because this guy, of course, is the hypotenuse. All right, fill them in. Let's see how you do. What do you think? Those match yours?
Yep.
Everybody okay with that? All good, no issues. All right, let's look at the next set. A little bit different situation. Question looks the same. Shoot, I shouldn't have erased all that. We're still finding all the same stuff. But this time, they actually told me that the sine was 2/3. And I have to find everything else. Well, one of those is a no-brainer. What do I automatically know if the sine is 2/3?
Hypotenuse is 2.
Well, I know the cosecant is
3/2.
3/2. Remember, these guys are reciprocal, so if you know one of these pairs, you automatically know the other one. Now, little piece of information here is really important. I know I talked about this with one class before, but I can't remember which class. When we draw our triangles situated on the coordinate plane like this one is, I've set it up for you that way. Theta is always the angle at the origin. So you're always going to put theta at the origin. Now if you have some random triangle sitting out in the middle of space somewhere, then I don't know where theta is. But if I'm on a coordinate plane, if I have axes drawn, then my theta will always be the angle at the origin. Okay? Now, if I could label the sides of that triangle, I could fill in all the rest of this, couldn't I?
Yes.
Can I label any of those sides based on what they gave me?
Yes.
Why? How?
Because the sine
Opposite
it's
over
opposite
hypotenuse.
over
Opposite over hypotenuse. So opposite
It's 2.
would be here and hypotenuse would be here?
Yes.
Now I have no idea what that third side is, but can I find it?
Yep.
Using the Pythagorean Theorem. And when I set it up, I'm going to be really careful because a squared plus b squared equals c squared, and c is the hypotenuse. So x squared plus 2 squared is going to equal 3 squared. Please be careful with that. I wish I had a nickel for every time kids set that up wrong. Make sure you've got the hypotenuse over here all by himself. All right, x squared plus 4 equals 9, x squared equals 5, and x equals the square root of 5. Now you already told me when you labeled it originally that this was the opposite and this was the hypotenuse, right? So this guy must be the adjacent. Now I can just fill stuff in. What's my cosine? Root 5 over 3, which means my secant is 3 over root 5, which I don't care for. So I'll make that 3 root 5 over 5.
Yep.
What's my tangent? Well, it starts out 2 over root 5, which makes my cotangent root 5 over 2, but I don't like the way this looks, so I'll make it 2 root 5 over 5. Everybody good? We'll do one more together and then I'll have you do a couple of them by yourself. Here we go. So again, our picture, we're going to set it up at the origin on the coordinate axis system. And we are told that the cotangent is 1/4. Now, before you do anything else, I want you to fill one more thing in this chart. What do I automatically know? The tangent is 4. Gimme points. Absolutely gimme points. All right, now let's come back up here. Let's remember that on the coordinate axis system, there's theta. So I know that the tangent is 4 over 1. SOHCAHTOA, that means what?
4 is the opposite.
Opposite is 4, and adjacent is 1. And I need my hypotenuse. So set that up for me. What's that Pythagorean theorem going to look like? Mm-hmm. 4 squared plus 1 squared equals x squared. So 16 plus 1 equals x squared. It looks like x is going to be the square root of 17. And that, of course, is the hypotenuse. 4 is the opposite, 1 is the adjacent, because you'd set it up using tangent, opposite over adjacent, right? Following along, folks? Ferris, you with me? Sine? 4 over root 17, so cosecant is root 17 over 4. Don't like the way that one looks, so I'll redo it. No radicals in the bottom. Cosine? 1 over root 17, so secant is root 17 over 1. Don't like the way this one looks, so we'll multiply top and bottom by root 17. And we are finished. Now I know some of you think, oh my gosh, Mrs. Ford, this is so boring. I'm sorry. Next time we're together, we're gonna have a quiz over this. Alright, so let's practice a couple more to make sure that we're ready. By the way, it won't be a group quiz, it'll be individual. Okay, so here we go. Let's try these last two. Let's try C and D. For both of those, please set up a picture like I did with A and B. Let's set up a picture that looks like this. That's the picture I want you to use for problem C and D. It's going to make it the easiest possible situation for you if you set it up like that for C and D. Now see what you can accomplish. I'll do it up here, but try not to look up here till you're ready to check your answer. But if you get stuck, look up here. By the way, I hate to interrupt your thought process, but remember when you're doing the Pythagorean Theorem and you're squaring the square root of 5, the square root of 5 squared is just 5. When you square the square root of 5. So as you finish, look up here and let's talk about, I could have made a mistake. I did it kind of quickly. I'm still all hyped up from math league, so I could have made a mistake. So let's talk about anything that we don't agree on. Evan's your hand up?
Oh, no, sorry.
Olivia, you match me or I match you on all this?
Yeah.
Hankins, you do it? You sure?
I mean, I am confused on that part.
What are you confused on, Max?
Okay, so like, I did this Socotello, like, I just wrote it
Are you
down.
talking about problem C or D?
No, it's problem C.
Okay.
So like, I just wrote everything down, like, try to memorize
Yep.
my base. So, my hypotenuse was 3, my opposite was 2,
Yep.
and then my adjacent was
Root
square 5.
5. Yep.
So, I got my cosine, and then my whatever you call that, across from
Secant.
right. but like the two on the top and two on the bottom, I got them flipped.
So sine,
Yeah, so like what I did was I did like opposite over hypotenuse, and I ended up getting like 5, root 5 over
okay,
2.
theta's at the origin.
Okay.
This is the opposite side.
Yeah.
So the sine would have to be 2 over 3. That's the hypotenuse.
Oh, I see what you
You sure?
mean. Okay, I got it.
Okay, because they gave me this one, right? This is the one they gave me. So adjacent over hypotenuse. The root 5 and the 3 have to be located here, so that is a 2 over there. Pushing your hand up, or are you just
I'll just stretch it.
stretching? Trying to stay awake. Audie, with me? You match on all this? Did you do it all, Audie?
Alright, well, not everything.
Okay,
I don't even know where I messed up.
okay. Somewhere we have a mistake with our Pythagorean Theorem. They gave me cosine. Cosine is adjacent over hypotenuse. You did adjacent over opposite, because they gave you this right here. So you put the adjacent was root 5, and then you put the 3 on the opposite and 3 belong on the hypotenuse. So the Pythagorean Theorem is messed up because you put your labels in the wrong spot. Your root 5 and your 3. Actually, the root 5 is right. The 3 is in the wrong spot. The 3 should be the hypotenuse. Oh, yeah, you're ready for that. We're doing that next. All right, anything else on C and D? Tomorrow's quiz, one problem. Well, actually, it'll be like this one, where I will give you one function, like I'll give you the sine. I will have them, because we're still memorizing, I will have them set up just like this. So you'll know these 2 are reciprocals, these 2 are reciprocals, these 2 are reciprocals. But you'll have to remember SOHCAHTOA, and you'll have to be able to label your triangle, okay? I'll have the picture drawn, but you'll have to put the sides in the right spots and do the Pythagorean Theorem correctly. Anybody have a question about that? We're clear on what the quiz tomorrow is, or whenever I see you again, okay? All right, now let's look at part 3, because now we need our gold sheet even more. We started, those of you in period alpha yesterday, we started talking about this yesterday, but not all of us had the opportunity, so we're starting from scratch. Without a calculator, we want to find the sine of pi over 6. So the first thing Olivia says is, that is a radian measure, pi over 6. I am not comfortable with radian measures because I just got introduced to them. So I'm going to change that to a degree measure. Pi is 180. 180 divided by 6 is 30. So what this is really asking me to find is the sine of 30 degrees. Now, that's not the answer. That's the question. You just rewrote the question. We're going to find the sine of 30 degrees. So, we're going to draw exactly the same triangle that I'm going to draw on your quiz tomorrow. Only instead of putting a random generic theta here at the origin, you're going to put 30 at the origin. That's your theta. That's your angle. Theta is the angle. You know it's 30. Now, in order to find the sine, you know what sine is. Sine is opposite over hypotenuse, right? So we need to figure out what the sides of that triangle are. Look at your gold sheet or dig it out of your brain. Do we know the sides of a 30, 60, 90 triangle? Yeah. We don't need the Pythagorean Theorem or anything like that. We know what they are. We have to memorize them. Across from the 30 is 1. Across from the 60 is root 3. And the hypotenuse is 2. Mrs. Ford, how am I supposed to know that? You're supposed to memorize it. You got to memorize it. This is going to come back over and over and over again in all kinds of problems. So please, please, please get it down. Across from the 30 is 1. Across from the 60 is root 3. And the hypotenuse is always 2. Shoot. If we know that, we're done. Opposite over hypotenuse. Here's your 30. The opposite side is 1. And the hypotenuse is 2. So the answer to the problem is 1/2. Isn't that amazing? You did that without a calculator. Let's try the next one. The tangent of pi over 4. Okay, let's go through the same steps. What was the first thing we did? 180 divided by 4. We said, you know, Mrs. Ford, this is just too much. I can't do radian measures yet. I want to change that to a degree, and that's fine. Pi is 180. What's 180 divided by 4? 45. So we're finding the tangent of 45. So we're going to draw our triangle just exactly the way we did it in those last exercises. But instead of putting a theta here, like our quiz will have tomorrow, a theta, generic theta, we had a 45. Now, what do we know about the sides of a 45, 45, 90? 1, 1, root 2. The sides are 1s. It's an isosceles right triangle. The sides are 1s, and the hypotenuse is root 2. Now we want tangent. Tangent, TOA, is opposite over adjacent. What is your opposite side? 1. What is your adjacent side? 1. What's the tangent of 45? 1. If you typed into your calculator tan 45 and you were in degree mode, it would say 1. Lydia?
When you're doing this, like the other one at 30, 60, whatever side you're finding, is that always the opposite, or is like number, or is like, or is the one always going to be the opposite?
No. The angle, whatever angle your problem is doing. So in this problem it was 30, that one's 45, it could be 60, whatever. That angle goes there at the origin. This will always be the opposite side. So if this had been a 60, the opposite side would be root 3. Oh, speaking of which, C says, find the secant of pi over 3. Pi is 180, so what's pi over 3? 60. So we're going to find the secant of 60 degrees. So there is the picture you're going to draw every time. You're going to put a 60 right here. And here we go. 30, 60, 90. Across from the 60 is what? Root 3. The other leg then is 1 and the hypotenuse is 2. There's your triangle. Make sure your triangle looks just like that. Now, you have memorized, or better memorized before tomorrow, SOHCAHTOA. Secant is the reciprocal of which one? Do you remember? Cosine. Cosine is adjacent over hypotenuse. So secant would have to be hypotenuse over adjacent.
Yep.
So let's look at our picture. Hypotenuse is 2, and adjacent is 1. So the answer to the question is 2. Are you starting to get a feel for how important it is that you memorize the stuff on the gold sheet? These problems are pretty easy. There's just a lot that you have to know. You know, Christina, I used to have a sign, maybe I already told you this. Did I tell you about the sign I used to have up there by the clock?
You haven't told any of us yet.
Haven't told you that story yet? Well, I used to have a great sign up by the clock that said, "Time will pass, will you?" I loved it, but admin made me take it down. Said it hurts your self-esteem.
Makes you question your life.
But let's try not to watch the clock. Cotangent pi over 6. Here we go. Step 1, Audie. What do you want to do first?
180.
Yep. That equals 30. So what we're really doing is finding the cotangent of 30 degrees. So I'm going to draw a triangle. And I'm going to put 30 degrees right there. Everybody good?
Yep.
Now let's label the sides. Here we go. 30, 60, 90 triangle. Across from the 30 is 1. Across from the 60 is √3, and the hypotenuse is 2. That never changes. That's always the same. Cotangent. Cotangent is the reciprocal of the tangent. Tangent is TOA, opposite over adjacent. So this is going to be adjacent over opposite, right?
Yes.
So adjacent over opposite would be what? √3 over 1, which is just plain old √3, because this is adjacent and this is opposite in this picture. Okay? Alright, there's 2 more. Try them. Try them on your own. See if you can do those last 2. Use your gold sheet as necessary. Try those last 2.
Let's just stay tuned.
We'll do these last 2, then we'll do a practice quiz for tomorrow, and then you'll be done for the day. Trish, you got both these down already?
Yeah.
What did you say the answer was to this one?
Root 2.
You're right. Where'd you get to this one? No. Oh, wait, yes. Yes, you're right. You're right. Good work. Oh, no, Max. We don't just write down the answer because Ferris said it. You need to do the problem. Come on, hurry up. I'll go ahead and put this first one up here, so if you want to check your answer, Ferris was right. The answer is indeed root 2. Does anybody have a question about the cosecant problem? All right, let's do this one then. Finish it if you haven't done that yet. That will not be on tomorrow's quiz, but that will be on another quiz we have later on. We okay? Don't want to rush you through it. Everybody get 1/2, okay, for the cosine of pi over 3? All right, somewhere over on the edge of your notes, on the back of your board, you know, a spare piece of paper on the desk, I don't care. Here's our practice quiz. This is what I'm going to do tomorrow. We're going to get a 1/2 sheet of paper. It's going to look just like this. That's what it's going to look like. And one of these will be filled in. I happen to fill in tangent this time, but something's going to be filled in. You will not have your gold sheet. So somehow, using your own intelligence and memory, you have to figure all this out. So what's probably going to be the very first thing you're going to do?
The 3/2.
Yeah. I would suggest automatically you fill in the reciprocal. That's going to be automatic points. You can't miss that. If the tan is 2/3, then the cotan will be 3/2. Done. Now to get the other ones, you're going to have to do a little work. Probably want to use your picture. Right? So what do we know if the tangent is 2/3? Opposite is 2 and adjacent is 3,
Yes.
because we're going to remember SOHCAHTOA.
Yes.
Now, I need that third side, so I'll do my Pythagorean Theorem. This is the hypotenuse, so I'm going to be real careful that the hypotenuse is the one that's over here. I got root 13.
Yep.
Now I'll fill in everything else, right? SOHCAHTOA, sine 2 over root 13. So cosecant is root 13 over 2.
Yep.
And then we'll fix this one. We don't want radicals in the bottom, so we're going to fix any of those. Cosine is 3 over root 13, adjacent over hypotenuse. And then we'll end up fixing that one. Any issues?
No.
No. Sylvia says, let me out of here. All right, I'll see you tomorrow for a quiz. Have a great day.
I will not make my day. Oh, it's okay. Oh, something left to do.
What?